Hello, welcome. This is going to be a lesson on system of equations by substitution. Um, we learned on the previous lesson on system of equations by graphing that whenever you have a system of equations, that means two or more equations. And when you have two or more equations, that means you're going to have multiple lines. For example, let's say I have two lines. Three things could happen. The two lines could cross each other and give you one solution, a point of intersection. Okay, that will be the solution. The second thing that could happen is the two lines are parallel, and that means you would have no solution to the system of equations. And the third option could be that I draw the two lines and one is on top of the other. In other words, they're both the same line. So that means every point on those lines are a point of intersection. That means they have infinitely many solutions. Okay? Today we're going to do system of equations by a second method called the method of substitution. Okay, so let's look at this example number 1. Here I have two equations, and one of them has the letter x alone, and the other one does not have the letters alone. Okay, for the system of equations by substitution, you have to have at least one of the letters by itself. It doesn't matter if it's x or y. Okay, in this case I have the x alone, so what I'm going to do is I'm going to put a circle around it because I'm going to select this equation. Okay, and then I'm going to want to come back to this equation at the end. Okay, so I selected this equation because I have one of the letters alone. Now with that in mind, I'm going to look at the second equation and I'm going to try to substitute. In other words, I know that x equals y plus 9, so I'm going to rewrite this second equation using that information. So that means whenever I see the letter x, I'm going to replace it with what is equal to, and we know that it is equal to y plus 9. Okay, everything else stays the same. Okay, so the only thing that is changing is the letter x. Instead of x, we open parentheses and we replace it with what is equal to. The end result of that is that I'm left with an equation with only one variable, the variable y. And basically I can just solve equations and solve for y. So basically, first thing I need to do is get rid of the parentheses. So I'm going to multiply. So this would be 5y plus 45 minus 3y equals 7. Now I'm going to combine like terms. So this would be 2y plus 45 equals 7. And then this would be 2y equals 7 minus 45. And 7 minus 45, we can do the calculator here. But remember, signs are different. You subtract. 7 minus 45. 45 minus 7 is 38. So it would be negative 38. Okay, but as I was saying, you can also use the calculator. So 7 minus 45. Calculator will give you negative 38. Okay, now let's go ahead and get the y alone by dividing both sides by 2. So this would be y equals negative 19, because negative divided by a positive is negative, and 38 divided by 2 is 19. When I use the calculator to do division, basically I don't write the signs because I can do that in my head, and basically I just use the digits. 38 divided by 2 is negative 19. So basically now I found that y equals 19. So what that means is that most likely what that means is that if I was to graph these two lines, I'm gonna get two lines that cross each other, and they cross at a particular point that the y coordinate is negative 19. So in other words, the answer for this system of equations already know that the y is going to be negative 19. Okay, now the only thing I need to do to finish is to find out what is the x coordinate is going to be equal to. And that's where that first equation that we circle comes into play again. We're going to copy it again. So x equals y plus 9. And using this answer that we found y, that y is going to be equal to negative 19. We're going to bring this up over here and we're going to substitute. So basically, we're going to replace letter y with negative 19. And x equals negative 10. Okay. Alright. So that means my answer, my point of intersection, is going to be negative 10, negative 19. Alright. Now, one way that we can use to check is to plug it in this information into the other equation and see if that's going to be true. If I plug it in negative 10 here and negative 19, my final answer should be a 7. So let's see if that works. I can use my calculator to do that. I do 5 times negative 10 minus 3 times negative 19. Okay? So hopefully this will give me a 7. And it does, so that means that's a confirmation that this answer is correct. Okay, so the answer for my system of equation is going to be a point of intersection. So basically, if I was to graph the two lines, they will look like two lines that cross each other, and they cross at this particular point. Also, let me point it out, using the calculator TI-84, you can also have the option of, instead of writing times, you could use the parentheses. Because remember, anytime you see parentheses, you mean multiplication. So if you have a number in front of parentheses, multiplication. Okay, so then this would be negative 3 parentheses negative 19. Whatever way you prefer is going to give you the right answer. Okay, so if you notice, whoops. Let's see, what did I do wrong? Oh, it's right here. See this negative here? Whenever you open parentheses, that negative has to be this guy right here. How do I know I did not press this button? See how this one is smaller than this? This means that the bigger one means I pressed the minus. The little one means I pressed the negative inside this parenthesis. So what I'm going to do, I'm going to rewrite this again and make the corrections. Now, you could write one by one, or you can do this special trick where you press second, enter, and that recalls back the last command that we had. So our last command had a mistake, so we're going to go back. I'm going to move the cursor over that negative. Okay, whoops, pressed too many times. Okay, now it's over there. See how it's highlighting over there? Now I'm going to press this and pay attention that that's going to change. Okay, I'm going to press it. Now, see how it changed? And if I press enter, I should get a 7. Yeah, so that means that this answer is correct. Okay? Alright, so this is system of equations by substitution. The whole reason for the name is because you're substituting. You're substituting once and twice. Okay? Okay, so let's go ahead and try another example. Here's okay, let's now do example number 2. So let's bring it to view here. Here I have two equations, and as we can see on this equation, these equations, none of them has the letter by itself. Okay, remember, system of equation by substitution, it does not matter which letter you get by itself. So we can choose whatever letter is easier for us. As we inspect these two equations over here, I notice that on the bottom one, the x is almost alone. All I have to do is move the 4y to the other side. So basically that's what I'm going to do. I'm going to move the 4y to the other side. So that means the x is left alone on this side. And on the other side I get negative 4y. And I bring down the 24. So as we can see, the y is alone. And that's exactly what I want. Okay? So basically what I did is I changed this equation into this with the x alone. So what I'm going to do is I'm just going to cross them out because I don't want to get confused. You know, basically I don't want to go back and use this equation anymore. I wanted to focus
on its new format with the x alone. Now the x is alone. I'm going to go back to the other equation that I didn't touch. I'm going to copy it down right here. So I have 2x plus 5y equals 15. And my goal is, method substitution, is to substitute. So instead of x, I'm going to replace x with what I know x equals to. And that's why I put a circle right there, because that tells me exactly what it is equal to. So it is equal to 4y plus 24. I'm going to bring down the 5y. And equals 15. So as we can see, when we substitute it, now we have an equation with only one unknown, the unknown being letter y. Now all I have to do is solve the equation for y. So first thing we're going to do is get rid of the parentheses, so this would be negative 8y negative 8y plus 48, and bring down the 5y equals 15. There we go. Now let's combine negative 8 with positive 5y, so that will give us negative 3y. Going to bring down the 48 equals 15. Remember, our goal is to get the y alone, so we're going to send the 48 to the other side. So it'd be negative 3y equals 15 minus 48. And this would be negative 3y equals 15 minus 48. Remember, you have a calculator here if you like to use that. Or, remember our rules, positive and negative signs are different. You subtract, so 15 minus 48 is 33. And you use the sign of the biggest, 48 being the biggest would be negative then. Or you can just use the calculator. We'll give you the same answer. Okay? Then, to get the y alone, we're going to divide by negative 3 on both sides. So let me pull it up a little bit. There we go. And we have here divided by negative 3. Since I have no more space, I'm going to move my answer right here to the side. Put a little arrow right there. There we go. And basically, the y gets by itself. Negative 33 divided by negative 3 is 11. So basically, I know that my answer is going to be a point. And my first coordinate is letter y. So I'm going to go ahead and start my answer here. Okay, I know that the second coordinate is 11. Now our job is to find x. How do we find x? We're going to return to that equation that we circled. So we're going to go ahead and copy it. Okay, and we're going to bring that y over here, and we're going to plug it in. So this would be x equals negative 4 parentheses, and we're going to replace the y with number 11 plus 24, and again we're going to do negative 4 times 11 is negative 44 plus 24. Okay, and signs are different, so you subtract. So it would be negative 20. Okay, so we found out that our x value is negative 20. Okay, now please remember, once you plug it in the 11 here, you can put this in the calculator, since we have this wonderful calculator. Negative 4 parentheses 11, okay, plus 24. See, basically I'm copying exactly what I have here into the calculator, and all I have to do is press enter, and voila, I get the negative 20. If you do not have this calculator at home, basically the steps will be similar, but probably your calculator will not have the parentheses, so you can do 4 times 11 plus 24 in that order, and the calculator will give you a negative 20, because remember, this parenthesis means we're multiplying negative 4 times 11. So there we go. Our answer for this system of equation is negative 20, 11. Okay. Remember, the cool thing about system of equations is that you can always check your answers. So since I got negative 20, 11, I'm going to use the first equation right here just to verify that it's correct. So basically I'm going to copy what I have, but instead of x, I'm going to replace it with negative 20. And then I'm going to do plus 5 parentheses 11. So if you notice, it's just like writing 2x plus 5y, but instead of writing x, I replace it with the value of x and the value of y. And if this answer here that we got is correct, then I should get the answer 15. So here it is, the moment of truth. Dun, 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 dun. We got it right, so that means it's correct. Just to be on the safe side, I'm going to go use the second equation as well. So 4 times 11 parentheses plus x, which in this case would be negative 20. So let's put negative 20. And if it is correct, it should give me 24. So here's the moment of truth. Dun, da, 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 da. 24. Woohoo! We got the right answer, so be excited about it. Okay. Cool thing about a system of equation by substitution is you can verify your answer. So there's no guessing. You can definitely be sure and be confident that your answer is correct. Alright, let's go on to the next problem. So let's go ahead and turn the page. And here's going to be example number 3. Okay. And we're going to still be using system of substitution. And remember, our goal is to get one of the letters by itself. It doesn't matter which one. And as I first look at this, I see that the y and the x is alone. Okay. But I see that to get the y alone would be the easiest one, because if I chose to get the x alone, I would move the y. I'll still be left with negative x, so that means I will have to divide by negative 1. But if I move the x to the other side and get the y alone, guess what? All I have to do is move the x, and there we go. We got one of the letters alone. So let's do that. Let's go ahead and move the x to the other side. So this would be 5 plus x, and there we go. See, all I had to do is move one letter, and there we go. So please remember, the first step of system of equations by substitution is get one of the letters by itself. Once it's by itself, then you just look on the second equation and you're going to substitute. That's why it's called the method of substitution. Okay, so basically here we're going to substitute the value of y. Everything stays the same, so 2x minus 3, but when we get to the y, we stop and we put parentheses and we'll replace it with what y equals to. So in this case, y equals 5 plus x. So we're going to replace letter y with 5 plus x. So do you see that I copied exactly the same, and the only thing that changed was that one value, that one letter that I'm substituting. Okay? Alright, then it's a very simple equation that you have to solve for x. So basically we're going to get rid of the parentheses. Alright, so this would be 2x. Negative 3 times 5 is negative 15. Negative 3 times x is negative 3x. And we can bring down to 9. Combine like terms, this will be the next step. So we have 2x minus 3x. This would be negative 1x. With the 15, we cannot do anything yet, so let's just bring it down. Alright. And now we're going to have negative 1x. I'm going to move the 15 to the other side. So this would be 9 plus 15. Alright. And this would be negative 1x. 9 plus 15 is 24. And that means we need to get the x alone, so we're going to divide both sides by negative 1. Gotta squeeze a little bit here, and I'm going to move the answer to this side here because we're running out of space. So, okay, and 24 divided by negative 1 is x equals negative 24. Alright, so that means we know that our answer is going to be two lines that cross itself, and they're going to cross at one point, and that point of intersection will have the x coordinate of -24. Okay, now the thing that we need to do is find the y value now. Okay, so to do that, always remember, go back to the equation that you circled at the beginning. Okay, and we're going to bring this value or this answer that we found, and we're going to substitute. Again, see how I substitute it and I substitute again? That's why this is called the method of substitution, because you're substituting not once but twice. And once I substitute it, then I'm going to have plus, plug it into -24, it'll be -24 here, and a positive and a negative becomes a negative. 5 minus 24, right? Signs are different, you subtract, so it would be -19. Remember, you can also use your calculator for positive -24, right? Or if you want to change these signs, you could also write 5 minus 24, because a positive and a negative becomes a negative, and you still get the same answer, -19. Alright? Okay, and there we go. There's our answer. Now, if this is a state test and I want to check, make sure that I'm going to get it right, remember, I can always plug it in. So let's say I plug it in right here on this first equation here. I'm going to plug it in -19 minus, and then the x would be -24. And here we go. This would be a 5, and that means it's correct. Let's double check with the second one. So if I do 2 parentheses -24, whoops, I hit double negatives there, so let me go back over there, just underline one of the negatives, and let's just delete that one negative, and let's move it back. Let's close the parentheses, -3 parentheses -19, close parentheses. Alright, let me double check if I copy correctly. 2 times x minus 3 times y. My answer should be 9. Here's a moment of truth. Dun, da, 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 da. Yoo-hoo! It is 9, so I am correct. I am on the right track. This answer is correct. Let's move on to the next problem. Example number 4. Alright. Okay, this is example number 4. Remember, you have a choice. What letter do you want to get alone? You know, if you notice right there, the y is almost alone. All you have to do is move the 3x to the other side. And there we go. That's what's going to happen. So let's go ahead and do that. Okay, let's move the y to the other side. So it'd be equals 2 plus 3x. The y is alone. Okay, and if you want, you can go ahead and cross it out here so you don't get confused. Or if you don't cross it out, that's fine. But I like to cross it out because then I'm focusing on these two equations, okay? And I noticed that on the previous problems I didn't cross it out. I mean, you don't have to, okay? But it's up to you. Alright, let's go back here. We have the y alone, so now let's substitute. The whole idea is to substitute. So we copy everything the same except for that one value that we're going to substitute. In this case, we're going to substitute the y, and so we're going to replace it, and we're going to plus 3x equals 4. Alright, so now let's get rid of the parentheses. So this would be 6x, and we're going to multiply here. So -2 times -2 times 2 is -4. -2 times 3 is -6 equals 4. And now I'm going to combine like terms, and look what happens. The -6 and the 6x cancel. So you left with -4 equals 4. What happened here? The x disappear. Okay, so this is a special case. When the letter disappears, either x or y, you left with a statement. Now you have to decide, is this a true statement or a false statement? In this case, -4 is not equal 4. Okay, so that means this is a false statement, because a negative is not equal to a positive number. Okay, and because it's false, then your answer is going to be no solution. Okay, and you can abbreviate with NS. If you remember, if I was to graph these two lines on a coordinate plane, that means I would have two lines that are parallel to each other. So the method of substitution helps me solve a system of equation without graphing. But by looking at the answer, I can know that the two lines are parallel. Alright, let's go on to the next example. Look at the next example. Always be on the lookout for which one will be the easiest one to get alone. And as I can look at this problem right here, I see right off the bat that x will be the prime candidate to get alone, because all I have to do is move the 2y and my answer would have, my equation would have just a letter by itself, and that's exactly what I want. So let's move the 2y to the other side. It becomes negative 2y, and the 6 stays where it is, so it's positive 6, and voila, I have a letter by itself. If you want, can go ahead and cancel this out, and let's copy the other equation. Okay. If you notice, sometimes I don't copy the equation. For example, let me move up to the first problem. This problem right here. Because I modified the first equation, that means I'm going to substitute into the second equation. So no reason to copy because there's space right there. Since I modified the second equation here, so basically the first equation is over there. So it makes sense to copy the equation and then to do the substitution. Okay, just a way to organize your paper so it looks nice and professional. Because the more professional your paper looks, the greater chance you're going to get higher points on your assignments and on your tests. Alright, so here's our first equation. We have the excuse me. We got the x alone. So we're going to substitute. Copy everything the same, except that instead of the x, we're going to replace it with what we have. So in this case we have x equals negative 2y plus 6, and everything else stays the same. Okay, remember to multiply. So this would be 4y excuse me. Okay, negative 4y, and positive 2 times positive 6 is positive 12, equals 12. And guess what happens here? The 4y cancels, so you're left with 12 equals 12. And guess what? The letter disappears. Again, we know it's a special case. When you have a special case, ask yourself, is this a true statement or false statement? This is saying positive 12 equals positive 12, and that is true. So we write true, and our conclusion will be, our answer will be infinitely many solutions. Okay, so IMS. In other words, if you were to graph these two lines on a graph paper, that means the two lines would be one on top of the other. Okay. All right. This concludes our presentation for this lesson on system of equation by substitution. Thank you very much for excuse me. Thank you very much for your time, and have a great day.